Hello students, welcome back. Today we're going to continue talking about Chapter 10, Sequences and Probability. We're going to finish up Section 10.1 today. We're going to do this last thing here. We're going to talk about summation notation. So I'm going to start with an example. Oops, you didn't see that. Shh. Okay, I'm going to start with an example here. This symbol right here is called a summation symbol. And here's this weird thing. Okay, so what does all this mean? Well, let me show you what it means and we'll see if we can figure out how we get it. So this means you're supposed to do 3 plus 6 plus 9 plus 12 plus 15. And that gives you a total of 45. So this has a value of 45. So if we look at this string of numbers here, what do you notice about these 5 numbers we added together? And there were exactly five numbers we added together. But hopefully you notice that all these numbers are multiples of 5. So if you think about it, this number right here is 3 times 1. This is 3 times 2. This is 3 times 3. This is 3 times 4. And this is 3 times 5. And you can also see that I have this thing that right here that says 3 times n. So basically the way you create each of these numbers is by using this formula. And what numbers do you plug in for n? You plug in, let's see, 3 times 1, 3 times 2, 3 times 3, 3 times 4, and 3 times 5. That's all the numbers from 1 to 5. So you plug in all the numbers from this to this into this formula, and then you add all the results together. That's what this symbol means. So this symbol is actually a Greek letter. It is the Greek letter sigma. It's a capital letter sigma. Lowercase sigma looks like that in case you're wondering. But it's the uppercase sigma. And it is used to represent a sum, also called a series. So basically, if you have this number down here is the starting value for n. This number on top is the maximum value for n that you plug into this equation here, and this is the equation for a general term, which we looked at in our last lesson. A sub n is the expression for a general term. This letter n here, it doesn't have to be the letter n. You know, in your formula you could really use any variable, but whatever variable you are using is right here, and that variable is called the index of the summation. So basically, sigma notation means this. Okay? So you add the first term plus the second term plus the third term all the way up to the last term, which here you can see is term number k. And the way you read this, okay, is you would say that this is the summation from n equals 1 to k of a sub n. So the way I'd read this is it's the summation of I equals 1 to 6 of 2i squared. And we're going to expand and evaluate this sum. So to expand it, I'm going to write it out like I did in this one right there. So I write it out by plugging all the numbers in from 1 to 6. So I plug in a 1 into this equation. That's 2 times 1 squared. Then I plug in a 2, 2 times 2 squared, then 3, 2 times 3 squared, then 2 times 4 squared, then 2 times 5 squared, then 2 times 6 squared, and I add them all together. So 2 times 1 squared is 2, 2 times 2 squared is 8, and then so on, 18, 32, 50, and 72. Add those 6 numbers together, and you get 182 is the sum. Next, let's try this one. Now notice, one thing that's a little different here is I'm not starting with the number 1. Okay, so this means it's the summation from k equals 3 to 5 of 2 to the k minus 3. So this time k is my index, and I'm not starting by plugging in the number 1. I plug in the number 3 as my first term, my starting term. So 2 cubed minus 3, and then I plug in a 4, 2 to the 4th minus 3, and then I go all the way up to this number, which would be 2 to the 5th minus 3. So that's 5, 13, and 29. I add them all together, and I get 47. So you'll notice this one only had 3 terms. So this number right here isn't always going to tell you how many terms they are. because you're not always starting with the number 1. That just tells you that's the last number you plug in, and this is the first number you plug in, and you plug in all the integers in between. All right, let's look at one that's a little bit tricky. What do you think of this? Notice this is not 4 times I or 4 times anything. This is just 4. So if I plug in a 1 to this equation, there's nowhere to plug that 1 into. So if I plug in a 1, all I get is 4. If I plug in a 2, all I get is 4. If I plug in a 3, all I get is 4. I plug in a 4, all I get is 4. I plug in a 5, all I get is 4. So it's just the number 4 added together 5 times. That's it. All right, now let's look at going the other way. So let's take this and write it using sigma or summation notation. So hopefully you can see the pattern here. I'm adding together 1 squared plus 2 squared plus 3 squared plus and so on all the way up to 9 squared. So basically, hopefully you can see that it's always a number squared. So that's going to, so really what this is 1 plus 4 plus 9 and so on plus 81, which I could figure out the total of that, but it's not asking me to. What I want to do is I want to write that using this notation right here. So basically the formula to get each of these terms is k squared. Or you could use I squared or n squared, whatever variable you want. That's called the index of your summation. And then the first number I plug in is a 1. And then I plug in 2 squared. And then I plug in a 3 to get 3 squared all the way up. And then the last number I plug in here means is 9. So that's the number that goes on top. This dot 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 means that also included is all the numbers in between. And this is what my answer would look like. Next, let's write the summation notation for this. This one is quite a bit trickier, but you'll notice there's a big old hint. And that hint is given to us right here in this last term. Notice that this last term here has a variable in it instead of a number. Okay, and this last term is the formula that can generate every term. All right, so what do I mean by that? Well, take a look at this. Let's start with this first one. If I plug in a 1 here, I will get 1 over 2 to the power of 1 minus 1, which would be 1 over 2 to the 0th power, which is just 1. If I plug in a 2 here, that's 1 over 2 to the 2 minus 1 is 1. So 1 over 2 to the first power, which would be 1/2. If I plug in a 3 here, I get 1 over 2 squared, which is 1/4. If I plug in a 4 here, I get 1 over 2 cubed, which is 1/8. This is the formula that generates this series. All right. Now, that means that for this summation notation, this is the formula that I use right here, except you'll notice that the last thing I plug in is n. Okay, so n cannot be the index. N cannot be the variable I use because n is actually the last number this time. In this case, it's a variable. So I could use any other letter I want. I chose to use a letter. That's the letter K there. So that's a K. So I basically took that and just changed it to a different variable, called it 1 over 2 to the power of k minus 1. So then K is my index. And the first number I plug in to get this first term here is the number 1, because when I plug in a number 1, I will get 2 to the 0th on the bottom, which would give me my first term, which is 1. And then the last term I plug in is n, because when I plug in an n, that gives me this last term right there. So that's how you can write the summation notation given the series. That's it for today's lesson. That's it for 10.1. Please let me know if you have any questions.